or stationary charges is known as electrostatics. The study of slow-moving charges or stationary charges is known as electrostatics. The study of slow-moving charges or stationary charges is known as electrostatics. But please, if you see an objective question and that objective question says one of these is what electrostatics is all about: A, charges at rest; B, moving charges; C, slow moving charges; D, neutral charges. The answer is simply charges at rest. Can you hear me? Or you say stationary charges. Electrostatics is simply all about stationary charges or charges at rest. The reason we normally put slow moving charges is because we believe that nothing is entirely at rest. So that is why you make room for charges at rest or slow moving charges. So please, if you check the notes, that question, the question I posted on the group, I personally broke those questions down so that I can use it to give you notes for today's class. So please read out question 1 for me here. Read out question 1 here. Instead of me coming to say, as you've written electrostatics, what is charge? What are the types of charges? I don't want it that way. So that I can touch those things I feel are very important. That's why I broke those questions down. So read the first question you have there. Go to Shaw A Academy, the tutorial group. Read the first question.
A is equal to...
A?
Is it that? The last one you sent.
Hey, Jesus Christ. Anybody on the group, let me see. People are looking very dull, very tired. Why do you be very tired? Are you a human being? That's one reason why you're tired. You are not just a human being, you're a science student. There should be difference between you and the exam team. Your reaction rate academically should be very high. That's why you're a science student. If you are a science student and you feel you are a human being, that means you are claiming to be here. You shouldn't be here. Okay, the question here is Q1 equals to 12 microcoulomb, Q2 equals to 22 microcoulomb. The one I got to electrostatics. Q3 equals to 14 microcoulomb. Then the man said, find the net charge. Find the net charge. So please, you'll be reading out so that I can hear. I don't have to be stepping down to come and check the question. Please, I'm using my own phone and I didn't come with the second one. So I can't be checking the question and be solving at the same time. So please, that question is simply to help me point out to you that when it has to do with charges, charges are calculated by the sum total of charges given to you. So whenever you see a question that has to do with charge, they tell you find the net charge. All you just need to do is to sum up all the charges there. That's the answer for the net charge, for the total charge. So since I have Q1, give me. Q1 equals to what?
12.
Microcoulomb, Shebi?
Yes.
Oh yeah, Q2.
22.
22 microcoulomb. Shebi?
Yes.
What about Q3?
14.
14 microcoulomb. What that thing is trying to say is simply add up all the charges. If I add it up, I know that micro means 10 raised to the power minus what? Is this 6? Minus 6, Shebi? First semester work. I will not do it too. So you will remember. So it's simply Q net is simply the same thing as saying Q1 plus Q2 plus Q3. So that this will give me 12 plus 22 plus 14, which is going to be what? Is it 46? 48. Sorry. So that is the Q net. So please, it is different from when they ask you to find force net or total force, F net. So for force net, for total force in an electric field, you do it by doing the vector sum. We'll get to that. But for charge, total charge, you do it by simply doing the algebraic sum of the charges. Am I too fast? If they give you charge to calculate, sum up all the charges, finish. If they give you force to calculate, you cannot sum up all the forces. You must do something I will teach you along the line. That's the simple thing I'm saying. So for that place that they wrote, calculate the F net as well. If you check, inside bracket, there's something like F net there. Should be? Yes. But they did not give us the force. If you check, they did not give us force. Is it not true? So that is why I will not solve for that force. I purposely put that F net. That question does not contain the force. But I want us to solve the ones down. Then we'll now go back to see how we apply solving force to this particular type of question. So just do as if you did not see that F net. That's what I mean. Read question 2 out to me.
Give charge.
So there I can clean. I read.
Give charge quantization formula. And explain.
Give charge quantization formula. Should we? And what? So first of all, what it means is that I should explain what quantization is all about. Shall you see it? So please, quantization is simply, you know that I don't like reading English. You read notes and do English. Quantization is simply talking about charges being discrete. By discrete, it simply means charges always exist in small quantities. It is not continuous. It does not exist as just a straight line like water flowing. No. It simply means that charges are linked up in chunks or in small portions to give you the final charge. So you don't have one particular charge, maybe say Q1 now, that will give you the whole charge that you expect to get for you to have an electric field. No. What it simply means is that for you to have an electric field to exist, there must be charge, or maybe a charge and another test charge, or different charges with one test charge. So the simple definition I want you to take for quantization of charge is simply, quantization talks about the existence of charges in portions or in small portions. The open bracket, you write chunks. The existence of charges in small portions or in chunks, which means that charges are not continuous. The existence of charges in small portions, which means that charges are not continuous. That is why you go to some textbook, you see something like NE. Charge equals to NE. It is that quantization that gives you this. This English, all this English you see me speaking, it is simply quantization that gives you this English. What quantization is trying to say is that if I know that charge exists in small portions, which means that electron will always be in every charge. I told you in our last class that electron is lighter than proton. Shebi? I said it in our last class. So those of you that might be looking at the class and it's looking like we are rushing it, is because I'm continuing with the same frequency of my last class. I fixed class on Monday, you did not come. So I'm continuing with the frequency and energy I used, the momentum for my last class. So I'm not going to be that relaxed, no. So next time if we say we've started class, you resume. It's not me, I will resume, you will stay in your house and be resting. Some people enter that Monday. You always like to see things happening before you join. So welcome. So I said, quantization is what gives you NE. Every charge must have electron. every charge must have electron. Electron and proton have the same charge, but we consider it in physics that the charge you have in every charge is actually electron, not the proton. Practically, we consider it that every charge moving is electron that you have there. But in physics, we can put proton and electron, but practically is the electron because the electron moves faster. So for that reason, charge quantization is simply talking about that for every charge, you must have sequential integers for that electron. Be it when n is 1, and you can't have n to be 2 when you've not counted 1. So you must have n to be 1 before n to be 2, before n to be 3, before n to be 4. So it's simply talking about those chunks must exist in a situation where you have this n to be integers. Okay, dot 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 to any positive n value, then multiplied by that e. So that is what it means. So if I ask you what is the number of charge, it simply means that maybe they give you something, they tell you the number of electrons, sorry, not number of charge. It simply means that you now make n equals to q over e. So please, let this n that I'm putting as integers not confuse you. The 1, 2, 3, 4 I'm putting there is to show you that it talks about quantization, moving from one particular value to the next, to the third, to the fourth. So it moves from lesser parts and going up. So I can't have maybe 2, 3, 4 when I've not counted 1. It has to go sequential in chunks. Am I confusing you?
No.
Okay, so please note it. For charge quantization, just write. Just write. Read question 3 for me. If it's confusing you, don't worry. If it's confusing you, don't worry. Just write, copy. We'll get to a point where all of us will be at the same page. Or is it on the same page? Read number 3. Superstition. Discuss the principle of superstition. And those of you that did not come on Monday, you did not experience my good news. And I only tell that good news once, so I won't repeat it. People that came on Monday are the ones that are aware of my good news. And the reason why I had to cut down my Africanness. I don't joke with my Africanness. But there's a reason why we had to take care of that. So please, those of you that came on Monday, help them with your notes. I beg you. We spent a lot of time on Monday. We started class by 12. We stopped around 2 thereabouts. And we didn't stop to discuss any relevant thing. It was notes, question solving. Should be true in class. So please, get notes from them, update your notes. We did a lot on Monday and I will repeat it. I will even resolve those questions. So copy. So they said, discuss the principle of superposition. The principle of superposition simply talks about, okay. I think speaking English is making it hard for me. If I have Q1, Q2, Q3, and I have a source charge, a test charge. Did your lecturer tell you anything about test charge?
No.
Did he tell you anything about source charge?
No.
But you're in chapter 2.
Yes.
Welcome.
We're done with chapter 2.
Okay, you're done with chapter 2.
Yes.
But we've not talked about source charge and test charge.
We have not started chapter 1.
Okay. Do you know my happiness?
No.
When you're in 200 level, you must be telling someone, any A1, Jekwe tutorial. Because this semester we must make sure we finish work. More like a same force. So that as you go wherever you are giving good feedback. So please, there's something we call source charge under classification of charges. You can have many source charge. You can have many source charge. You can have many source charge. But you will always have just one test charge. Note that you can have as many source charge, originator of charge as possible, but you only have just one test charge. So for that reason, principle of superposition is simply talking about the algebraic sum. That's when I started with the algebraic sum of all the charges or all the forces in an electric field. And when it has to do with forces, you do the vector sum actually. So for charge, superposition is simply talking about the algebraic sum of all the charges in an electric field. So all these charges, summing it up, as we start doing the example, you see it. We've not gotten to electric field. I said superposition is simply the algebraic sum of all the charges. The algebraic sum of all the charges in an electric field. Don't worry. I'm putting it that way with my own English. As we progress, it will make more sense to you. So, right. The algebraic sum of all the charges in an electric field. Have you written it? Yes. It can also mean the algebraic sum of all the forces in an electric field. And you know that summing up force, you use the vector form to sum up force. Are you aware? So you can say the algebraic sum of all the vector forces, however you want to put it. So that's what superposition is talking about. And please, when you are doing superposition, it simply means that Coulomb's law can no longer work. Can you hear me? Remember that Coulomb's law only works for point charges. Did I tell you that? Coulomb's law only works for point charges. So whenever point charges, whenever you are not having more than like you should have for charge, you will now introduce principle of superposition. Just be writing all these things. It's not supposed to make sense immediately to you. As you start solving questions, it will not start making serious sense to you. So I said Coulomb's law only works for point charges. You dig it? So just be writing. So you now know what superposition is, Shebi? Okay. But you don't know what source charge is, so you don't know what test charge is. Your own is that you've written. We will see what everything means as we progress. But I read the next question. Read the next question. Hello? Types of charge. Okay, so please, we have two major types of charge. We have the proton and the electron. The proton is the positive charge. The electron is the negative charge. And you know that in your secondary school they told you about Crook, the man that did cathode ray experiment before J.J. Thomson now came to now name it electron. That's why you're a science student, you should remember. So you've done. Do you still remember? Yes. So what we are saying is that when it has to do with charge, proton and electron, two types of charges. But you now need to know that proton, the positive charge, always starts from the origin, while charges terminate at the negative axis. Am I too fast? No. Charges start from the positive terminal and terminate at the negative terminal. You say at the negative charge. We've already illustrated how charges move in our last class. Don't make this a joke class, please. Charges start from the charges originate from the positive terminal and terminate at the negative terminal. Or you say at the negative charge. Welcome. If you missed my last class, what I'm doing today might look like incompetence to you, because I know I took time to explain most of those foundations. And I'm not happy that you people did not come for that last class, because people that came for the last class, I don't think we're up to 20 something that day. Yes. So please read the next question. Classification of charge, right? This is where I now explain what source charge and test charge means. So please, for classification of charge, you have what we call the source charge and what we call the test charge. What we call the source charge and what we call the test charge. What this thing means is that, for example, see, please watch. If I have a charge Q, we know that charge is represented with Q. This source charge can be positive, it can also be negative. It simply means where the charge is starting from. So a source charge is a charge that creates electric field. A source charge is that charge that creates electric field. The classes we are doing Monday and Thursday forms the foundation of everything you'll be doing going forward. There are some of you that with time, what you will do is once you see question, you cram how they solved it. You see it in another place mixed up, you won't know how they did it. Maybe they give you like up to 4 Qs. You'll be making mistake because you don't understand these basics. I said a source charge is the charge that creates electric field. Electric field don't just happen on its own. It's a charge that will create it. That charge that will create the electric field is what we call the source charge. It can be positive, it can be negative. While the charge that will be attracted or repelled, the charge that will be attracted or repelled or that is acted upon by an electric field is what we call the test charge. Am I too fast? Yes. I said the charge that will be attracted, repelled, or acted upon by an electric field is what we call the test charge. I know in your secondary school they told you force field is the region where physical activity take place. They now tell you gravitational force field, they tell you electric field, magnetic field, all those things. Whenever it has to do with electric field, for that electric field to exist, there is a charge that causes electric field to be created. And you know that for that charge to be there, that means electric force is felt. So that electric force that is felt, whatever is feeling it, whatever charge that is feeling it is what we call the test charge. But the one that created it is what we call source charge. Thank you. So if I have, for example, this to be Q positive, and I have this to be Q negative, automatically, this charge, one of the charge creates the electric field. Somebody wants to ask me, how do you know the one that will create the electric field? The bigger charge creates the electric field. The test charge is always small. And remember I told you that in a number of charges, you can only have just one test charge. So the bigger charge creates the electric field. So if it creates this, because this is negative, what will happen? It will attract it, shaping. So that means that signs are important. If I have positive and negative, what will happen? Attraction, shaping. Is it not true? Attraction will happen. And if I have, even if it's negative and positive, let's say I change it this way because of some people's way of wanting to think about everything. Attraction will also happen. But if I have positive and positive, what will happen? The portion, shading. If I have negative and negative, what will happen? I remember in my last class, I told you the true test. I told in my last class, the true test of charge is what? The portion. Okay. So see, for that reason, if this is the test, the source charge, and this is the test charge, if this test charge is outside, it cannot feel this electric field that has been created. But the minute this test charge is brought somewhere here, inside this electric field, it will feel it. It will feel it. It's just like if you have your magnet, if something is far, something it can attract is far. That thing will not feel the magnetism now. It will not be attracted. But the minute you bring it very close, it's feeling it immediately. Is it not true? It's the same case here. So if that be the case, because these charges are different, this one will be attracted to this. And notice that it is moving towards this. It is moving towards the source charge. Is it not true? It's very important to know this because there's a question there that says using sign convention to check if the force in an electric field is repulsion, repulsive or attractive. You see questions like that. They might finish asking you a question, then ask you, what type of force is that? Is it an attractive force or a repulsive force? So this is how you get to know it. So for the fact that this charge is going to be put to the source charge, reason being that they have different signs. That is the sign convention. If the signs are different, the test charge will be put to the source charge. Are you seeing it? And because this type of charge, this type of electrostatics is attraction, that means the force here is going to be an attractive force. Are we together? So for attraction, when the signs, another way to put it is, when the signs are different, the force you have here is going to be an attractive force. Attractive force, attractive force. Why this one will be repulsive force? Repulsive force. So if you know this, so it's not important to me for you to know how it moves. So a situation whereby I have, for example, a negative charge, a negative Q, and I come and bring another negative charge, the test charge, inside this electric field that has been created by this one, what do you think will happen? It will repair, Shebi? Repulsion. And because it is going to be repairing, watch only wire, watch this thing, don't meet price mesh, not remove you from this. See, if this is going to repair, notice that this will be going this way, is it not true? This will be going this way, is it not true? We simply say that for the fact that this test charge cannot be drawn to the source charge, once the signs are different, you show that the force moves away from the source charge. Once the signs are different, you show that the charge or the force, moves away from the source. So that means that in a case where I have, you will see these questions, you will see it. So if I have Q1, Q2, and I have this to be negative, this to be negative, and I'm looking for the force. I'm looking for the force now, if it's attractive or repulsive. I'll ask myself, the signs here, are they the same? They are the same, Shebi? Now, if we say that this is the source charge and this is the test charge, I said, since the test charge, normally test charge should be drawn to the source charge that is bigger, if it's attractive. But since the test charge cannot be drawn to the source charge, it will be moving away. Is it not true? Out of it. So the force is going out of the source charge, is moving out the force. So for that reason, for the fact that this is negative, and we said this is the source, instead of going to the source, it is going to be moving out. Are you seeing this thing now? Yes, you better be saying it. So because it is moving away from the source, we said that this is a repulsive force. And you notice that in most cases, you always see that your force is positive for repulsive. It doesn't mean that if the charges determine it to turn this to negative, that you now call this to be repulsive force. It is an attractive force, but you must obey the sign convention. Am I speaking so many things?
Yes.
Yeah. We've not even done capacity, resistor, electric field intensity, Gauss theory. But let me take it gradually. I said positive and positive will give you what type of force? Negative and negative will give you what type of force? Negative, positive will give you what type of force? Positive, negative will give you what type of force? Attractive, Shebi? I am not saying that, let's say we have Q1. We can even have up to Q3, but we are starting small before moving to those big ones. Because we must do everything and you must understand everything. If I have this to be like positive, I have this to be like positive. What I'm looking for, a question is given to me. And this question given to me, I find out that the two charges I have are positive. I need to find the type of force. Yeah? I am not telling you that to find the force, all you need to do is to ask yourself, if it's positive and it's positive, it's going to be repulsive. That means that the test charge, the one that, let's say the test charge is now here. and let's say the source charge is now here. For the fact that it's going to be repulsive, this test charge cannot come and meet this. Rather, it will be pulling away. So the force will be going away. Because normally the test charge should go to the source charge. But because it can't go to the source charge, the force is going to be pulling away from the source. Are you saying it? It's not my fault that you did not pay attention when you were growing up. It's not my fault. I will not put it inside your head. So going away is going to have this to be this way. So you see that this is F. Oh, watch. This is F because it's going away from the source, right? But notice something. Naturally, anytime force is moving to the left hand side instead of right hand side, that force changes to negative force. Is it not true?
Yes, it's true.
So for that reason, this force ends up being a minus force. So the effect you have with such a force that whenever you finish and at the end of the day, the direction of the force is going towards the left, the effect you have due to the direction is going to mean that the force is an attractive force at the end of the day. Is it confusing?
Yes.
It is confusing you because you saw the minus F there. And I'm trying to tell you that first, the rule is that first, you must obey the sign convention. You must obey the sign convention. That is the first rule. Once you don't obey the sign convention, what you did is just magic. You are just imagining. The sign convention determines. Now, when you find the sign convention, you will now ask yourself, is it supposed to go towards the source, away from the source? If it's going away, the reason why this one has to be negative, like it ended up in this way, is because the test charge on this O was put in the left hand side. That's the reason why. The test charge on this one was put on the left hand side. And if you notice, most of the experiments you do in physics, it's almost as if they always start from the left hand side, putting positive there, and then putting negative on the right hand side. So the minute you go and try to use one knowledge to round it up to favor you because there's something you want to see, you fail the whole thing. So the key thing is the sign convention. It's not your fault, it's not your business that whoever said the question had to put the test charge on the left hand side. It's not your business. Are we together? Yes. So note that. So with that said, if you don't understand up to this point, don't worry. You will understand as you start solving question. Give me the next question.
But can you also just when F is going anti-clockwise direction?
When F is going anti-clockwise direction.
When the test charge is at the left.
We've done the two now. This one is not when test charge is right. This one is not when test charge is left. This is how we normally do this in every semester. You finish, you solve just one topic. Alright, let's take another example. Alright, use your hand now. Give me a question. Give me the arrangement how you want it to be. Let me explain so that we move to the next question. By the time we finish solving the whole question, I know you understand. Use your hand now. Give me the question. How you want me to set it up now. You know that we have types of charge and classification of charge, Shebi? We know that type is positive and negative, proton and electron. I have told you that the charges are the same. The charges will always be the same. 1.602 times 10 raised to power minus 19, Shebi? Yes. But the masses are different. Proton is heavier than electron, which is why we say that electron is lighter and will always travel faster. And which is why we say that in every charge you must have electron. That is why for charge quantization, you have that charge is simply talking about number of electrons. If somebody chooses to say number of proton, it's still okay, but it means that that person don't understand that electron is lighter and what travels faster is what you should work with. So if I know that, give me your own setup now. How do you want me to arrange this thing? Do it, say, so that I know what I'm answering, so that I can clear you. Ask me. Give me the next question. Give me the next question. Minus and plus, like, Where do you want the minus to be?
At the left hand. Then plus. Then source and.
Okay. So let's say I call this one Q1 and I call this Q2 or Q0. Anything you want to call it, no problem this business. But which one are you calling the source charge?
That is the negative. That is the source.
Which one should I call it?
The negative.
Which one should I call? This one becomes test now, Shebi. And do you remember I said that you can have as many source charge as possible, but you can only have just one test charge. Yes. And do you remember in our last class I said that electric field line can never intersect or cross each other? Yes. Shey, you still remember? All these little rules will guide us when we start solving big questions. So if I know that, let's say I have these two charges now. Normally, we know that it should go this way, but I'm using this so that I can be able to illustrate what I want easily. Because we said that charges move as a curve, not as a straight line. We gave that rule. So if I know this, I want to get the force, if it's attractive or repulsive. Now ask yourself, when these two things, this is the source one, when these two things are of different charges, what type of charge do you get? Is it attraction or repulsion? Attraction. And whenever we have attraction, we must have attractive force. But notice something. I've put F here. Now ask myself, if it is attracting, will the test charge go and meet the source charge?
Yes.
It's going to the source charge, right? Yes. So I put this like this. Now notice something. I've put this like this. That means what you get me is not even complex. This one is not complex because already the force is going in the left hand side now. If you remember that time we said forward force in first semester, backward force. Backward force always having negative, forward force always having positive. So for the fact that the force, anytime force is going to the left hand axis, it means that it's going to have minus. You get the point now? So it's an attractive force, and naturally, by right, anytime you see minus F, that type of force is an attractive force. That is why I said no matter how the arrangement goes, provided you followed all the rules I've given you, and you end up having the F to come and have minus, have it in mind that I said F that has minus is an attractive force, and F that has positive is a repulsive force. You get the final conclusion, but the final conclusion you get don't determine your process. You must follow these processes that I've given you to arrive at your conclusion. So how they arranged it in the start, putting this one here, putting this one here, is not your business. We are human beings, we can put things how we want. But the process must be followed. So if I know that I've answered this question enough, let's go to another thing. Oh yeah, give me the next question. Read the next one. We've already done it. It's this one. Oh yeah, the next one.
Giving charge.
Giving charge.
Plus Q1.
Giving charge plus Q1.
Minus Q0.
Minus Q0. Plus Q2. Is it like, but read the whole thing, let me hear.
And F10 equals to 5N.
5 and F20 equals to 9.
Like, see, let me write what you are reading, like, so that I will understand. Giving, minus Q2. Minus Q0,
Plus Q2.
Plus Q2,
And F10 equals to 5.
And F10.
And F10 is equal to 5.
And F10 equals to
5 Newton. F20 equals to 9 Newton.
9 Newton.
Find the F10.
Okay. Oh yeah. Shebi, I've told you, you always put your solution. So giving charge Q1, Q0, Q2, and F10, F20 equals to 9 Newton. Find the F net. Is that all they gave us? Even charge plus Q1, Q0, Q2. Okay, yes, okay. Yes, okay, we are good to go. So see, I will have, once you are given more than 2 charges, it simply means that that person is pointing you to understanding both Coulomb's law and superposition. So what you're now going to be applying is your sign convention. See what I mean? Let's say I have this to be Q1 positive. Let's say I have this to be Q0 negative. And let's say I have this to be Q2. Let's say I have this on it. Now see, what tells me that one is test charge or that the other one is source charge is simply one thing. Come to your force. Come to your force. This F10 you see here simply means anything that comes second in the number. Don't come and think this is like mass where you're doing F20, F22 or what. No. Anything you see here is simply talking about the source charge and the test charge. Notice that here you also have 2, but you still have the same 0. Because test charge will always be 1 in that thing. Test charge will always be 1. So that one that is having knots there is the one that is the test charge. So this 2 0 simply means force acting on charge 2. Yes, force acting on charge 0, sorry, due to charge 2. Due to charge 2. Reason being that due to means that Q2 is a source charge. On 0, charge 0 is test charge. Remember I said 1 creates the charge. 1 experiences the charge. Is it not what I said? Or experiences the force on that field. So when you see this 0 and this 0, it means that that charge that is carrying Q0 is a test charge. You can see that it is here and is also here. Another way to know it is that the thing that comes second or the thing that comes more as you are checking your force is the test charge. They don't have to tell you that one acted on or that one is due to all the time. They can just put it this way so that you simply know what you are doing. So it simply means that because I've seen my force having 1 and 0, having 2 and 0, automatically the one that has 0, the charge that has 0 is the test charge. That means this is source charge, this is a source charge. You can have many source charge but just one test charge. So for that reason, I come and say, okay, if that be the case, this is going to be a test charge. This is going to be a source charge. And this is going to be a source charge. And this is the reason why some people, when they read this thing just in textbook, when questions come and they give you more than one charge, it's looking as if you are mixing things up. Okay? So, now check something for me. The sign here and the sign here, are they the same thing? So if there are different signs, attraction will occur, Shebi? Yes. That means that if I have a force that is here, and remember, 1 and 0, the force here is that your F10, which is the force on Q0 due to Q1. And the force that will be here will be force on Q2, on Q0 due to Q2. This is how you put it. I know somebody will want to say, why don't you put the test charge before this one? No, now, you will have a source before the test. Is it not true? So physics is not hard. It's still relating to the normal things you do every day. It's just that you will now have to be putting the small pieces together. So see, if I've noticed this, the next thing now is to find the signs that will be on this charge. The signs that will be on this charge, very important. You don't just say because attraction is occurring, that means automatically, let me say it's an attractive force and the sign will just be negative. And because repulsion is happening, let me just put positive and the sign is going to be just repulsive. No, you will determine your sign by the signs, the sign for your force, using the signs on the charges. You will determine the sign that will be on your force, no matter you knowing if it's an attractive or repulsive force. The charge that will be on those forces will be determined by you knowing the signs or by you making use of the signs on the charges there. So for that reason, this is negative, negative. test charge is going to be going towards the source. So for that reason, it's going this way. Anytime force is going this way, this is minus. This is source. This is negative. Attraction will occur, Shebi. And that attraction, once you dictate that it's attraction, or yes, what it will now help you to do is to say, okay, because attraction will occur, it means that the smaller charge will easily be moved to the bigger charge. So this will easily move here. It will go like this. So this one is in order. Most of the time they give you in order. All these ones that we are confusing ourselves is because training is supposed to be hard. So that's why sometimes I add my own confusion in the question. But this one, I know this one is like a question you see even on like all these past questions. And I believe the app, Akada app, you will notice that from now till next week, you notice that wherever you have as your last page there, you have more pages that will have the past questions. So I will announce still. So now that I've gotten this, now that I've gotten these two things, I can now easily come and say Fnet will simply be the same thing as saying forward force. Do you remember?
Yes.
If you remember, or you say Fnet is simply the total force is there, and Shebi. And when you do total forces, backward force there will always have negative sign. So it's the same thing as saying forward minus backward. So this is going to be the same thing as saying F20 is okay. Yes. F20 because they did not give me any value for. They did not give me any value for that. The mistake most people will make, we have thinking faculty. Good number of you will say since positive proton and electron has a constant charge of 1.604 times 10 raised to the power minus 19. Anytime you are not giving charge, your mind will tell you to rush and go and put it for the charges. You will fail. Charges will always be given. If it's not given, that means there's something they require you to do. So what I'm going to simply do here is simply going to be my 9 minus 5, which is going to give me what? 4 Newton. As simple as that. Very simple as that. So this thing now, you see this thing that we've done here is still under what we call principle of superposition. But you don't add force by just adding force directly. You need to find the sign convention, whether it's attractive or repulsive, what sign the force will carry before you add it. So once you found out, you now do what we've done here. So that is how you go about it. So let's check. Okay, why you are. He said when it involves attraction, it's usually negative.
So I was thinking that since both of them, since the test charge is attracted to the source on both sides,
Finish what you're saying. Like, come again.
since there's a test charge at the center, that's minus G0. It's supposed to be attracted to source charge on both sides. Since they're opposite.
Okay, it's supposed to be attracted to source charge at both sides.
That's according to explanation.
Okay.
So it's supposed to be minus.
Okay. Well, see, let's check something. Shebi, this is the test charge.
Yes.
Let me use your English. You're supposed to be attracted to the two source charges, Shebi. Your English is what I'm using. If you go here, you go here. Shebi, you see now what he's doing? When show me the direction of somebody that is going here. Is it not like this?
I'm saying it based on what you do, because you see that it's going to be minus. So I was thinking that when you were doing that,
Did you hear when I said that before you check the repulsive that you know and attractive that you know, you must first check the sign convention and the direction of that force. And I said that if it's moving forward, your force is positive. If it's moving backward, your force is negative. So please, if you are quoting me, quote me completely. Not quoting me from how you want it. But thank you for that question, because we are clarifying a lot of persons. The first thing is the sign convention. You will always look out for the sign convention. The second thing is the direction of the force. Because we know that force is a vector. So I cannot treat force without knowing the direction. So once you've gotten it, before you now determine if it is going to have a negative or a positive charge. Just the way we are doing it, that is how you do it. Think accordingly. Not have fun. Don't skip anyone. You always be in line with me. Okay. It's going to be what? Why do you think this minus is here? Too much thinking. Too much thinking. See, by right, what I'm supposed to just have is to say the forward force, which is F20 plus F10. But because this one is adding minus to it, it influences this. Is well. Is well. Finish this one we are doing now. Shall you see that question 9 and 10 that we solved, that we stopped at in our last class? That's your classwork. You now solve it before we start maths. So for Coulomb's law simply says that, and I told you that before Coulomb's, the first person that gave that law, the law you call Coulomb's law, the first person that gave the law is the man we call Michael Faraday. Even all those things you see, drawing F and F2 and all those things, is Michael Faraday that started it. And that is how life is. I see some people online, some students that will come online, where some students are talking, you see somebody online, the person will be saying, Anambra is better than Enugu, Enugu is better than Anambra, is in Anambra where they will give to them, is in I say the queen idiot, move people. Anambra and Enugu, the same place, one, just that Gowon wake up one morning because he's fighting battle with Ojukwu and decided to be splitting states. By right, if you are an Enugu man, you are an Anambra man. This is the truth. By right, if you are an Abia State man, you are an Igbo person. By right, somebody in a boy, is from Enugu. See, the only problem, me I will say it, so even if you are from a boy, it's not bad thing, so that you level up. So you don't think it's the same thing. The problem you see most states have with a boy is not that we are not one. It's just that mindset of where you say you are the one that is down, others are high. They should see you as somebody that is down. And as an Igbo man, you'll be like, how can you be thinking that way? So how can somebody give you a house for rent, for example? House for rent, accommodation, where for 2 years. In that 2 years, like up to 5 people from your village are staying in that same place. One room. It's only Hausa people that have that habit. You understand? So as an Igbo person, let's tell ourselves the truth. You start thinking it one kind. So that is how that thing got that far. People start to look at it that way. If you go to Anambra, the cheapest place to get house in East is Anambra. All these guys you see people doing with agency, they don't do it in Anambra. Houses everywhere. You see like up to 6 decades. The way a landlord do to the house, yes. So if they come and give you the house, they expect you to be somebody that know how to coordinate it. Then you come and bring all your village people inside that place. The news will fly. That is how you started flying. So it's not like we see people different. You know, we are one. But if you are seated here, and you're from a boy, no sentiment. Have it in mind, your own structure, that you shouldn't be that way. That your own structure should be in a way that you know how others are coordinating things. You just coordinate your own like that too. So that's just the problem. So, Coulomb's law. I said, Coulomb's law is attributed to Coulomb's, but it started with Michael Faraday. And he stated that the force of attraction or repulsion between 2 charges. What we are writing? The force of attraction or repulsion between 2 charges. The force of attraction or repulsion between 2 charges. The force of attraction or repulsion between 2 charges. Here you see that his law has limitations. Once he passed 2 charges, that means principle of superposition must be introduced. Are you seeing it? So he said that the force of attraction or repulsion between two charges is directly proportional to the product of the charges. The force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the square of their distances apart. Coulomb's law, and it favors just point charges. He said that the force of attraction or repulsion between, in fact, put 2 point charges so that you remember it. Between 2 point charges, force of attraction or repulsion between 2 point charges is directly proportional to the product of the charges. Let's use of the charges. And inversely, or is saying directly proportional to the square of their distances apart. That's Coulomb's law for you. That point charge, very important. Putting point charge there, very important, so you remember it. So that is what Coulomb's law is all about. Now the limitation, I will still give you the mathematical representation, but the limitation to this law is just the fact that it is concentrated, or it deals with just point charges. It deals with point charges. That's the limitation. So once the charge is not a point charge or is more than 2 charges, even if you have to use Coulomb's law, you must employ the principle of superposition. Make your own notes. Know how you think about what I'm saying and put it down so you remember. It's not the one I say and I said it fast, you say no need. This is April. In fact, this is as good as May. Sure you know. It's as good as May. June, July. By August ending, all you'll be thinking about is how you are in 200 level. Sure you know. That's what you'll be thinking about, how you are in 200 level. Then by September, what you'll not be doing is on your group chats, brainstorming for 200 level. Your course rep must have created group, added some of the departmental lecturers. They will not be telling you, this is what you do, this is how you do, this is By October, you should be a 200 level student. All of you, 200 level students. Now see, when you enter that your 200 level, you will relax. You will be doing your business as a 200 level student. Shebi, we taught you, you did well. In your mind, you believe academic daddy them, they are fine. Shebi, and you're doing your 200 level. In your mind, you are fine. But guess what? Your course reps, as you see them every day, they are also here with us. By the time you be in 200 level, they will be here with us. Not physically, but on group chats. What are they doing? Everything that you feel we said that went contrary to their own interest, they will use it as an energy to say, that time we're in year 1. Academic daddy will come and say, students should not do this. They will not enter groups, start writing things. You witnessed it in your own year 1. When you started year 1, you witnessed it. There are some group chats that you were on. When you started school, where you come, you see people posting, don't go tutorials, so don't this one, oh. If you tell yourself the truth, when you started year 1, you witnessed it. So people coming will also witness it. Why am I saying this? It's not your own job when you enter 200 level to tell people coming, go for tutorials. So. Reason being that some persons feel that as adults we are in this place, that when they are called, that we should break protocols and say all of us are men. No, we are not men. You must reach a certain height. What you have is the respect for doing things right. Once you start to go against the rule, you will be, some things will go against you. So you don't believe that we should just overlook you because you are men, or that we should treat you as equal. The respect will be there to show you, yes, we understand how things operate, but not you doing how you want. So please have it in mind. Why I'm saying it is so that it just stays there, because we don't emphasize this enough. I feel we don't take time to emphasize this the way we should do. Because I believe, even without us interfering, assuming we emphasize it enough, there are some things that if they are posting and maybe someone just come to you, you even be the one to say, I want to fight for it. Yes, now. You get to a height where if you are doing very good, people will be fighting for you. It's true, it's obtainable. You get to a height where you know that you maintain certain standards, and no matter what happens, you have strength of character, you can't break. People should fight for you. So why I'm saying it is that I want you to have it in mind. I'm emphasizing it. So it strongly stay in you that as you enter 200 level, all of you are not entering 200 level. Some people will come to do A-watching. There's something we call A-watching. They don't allow us to make money. They don't allow us to put on the way we want. We go now do our own. They will create good chats and be posting what they like. So it's up to you to have it in mind. I will be saying it over and over, not just today. So please, under the limitations of Coulom's law, it only favors, or it is only valid for point charges. It is only valid for point charges. Simple. Just like that. Simple. So please, you will see what we call corona discharge. I believe in your assignment, one of the assignments they normally give you when school starts is what is corona discharge and the rest. And when you start reading that thing in the textbook, it looks plain, it looks difficult to understand. Anywhere you just see corona discharge, just take it as ion or ions or air getting ionized. See what I mean? If I have positive charge in engineering, most of you won't really understand this the way I'm seeing it. I studied engineering, first degree. And that engineering, most of the things you'll be doing, like if you see all these testings you're doing, you notice that as something is connected, when the charge is too much, it's doing crrrr. When the charge is too much, you notice that you even be seeing sparks around it. Is it not true? You must have witnessed it before, or if you've been watching videos where somebody is telling you that they have charge, all these cartoons, then you notice that as the person passes current, you notice that there are certain lines that break out. Then you see in the air, that thing you are seeing, that sign you are seeing, that signal is what you call corona discharge. Air getting ionized. That's just what you call corona discharge. So you note that, I might forget, that's why I'm pointing it out, so that in objective, a still form part of what you are, what you easily pick out. So read the next question. Read the next question. The next one.
2 charges plus Q1 and plus Q2.
But wait, it's like this calculation. You got 2 charges,
Plus Q1
Uh-huh.
plus Q2.
Are separated by distance R.
Are separated by distance R, yes?
The charges tell each other.
Charge is pressure
with a force F. If the distance between the charges
if the distance between the charges
is reduced to 1/3.
is reduced
To 1/3.
okay.
Calculate the resultant force.
Calculate shall we calculate the resultant force. So two charges plus q1 and plus q2 are separated by distance r. The charges repel each other with a force F. Full stop. If the distance between the charges is reduced to 1/3, calculate the resultant force. Okay, so let's solve. Let's solve. Solution. Please, if you are here, you've not paid us for tutorials. Each time here we have tutorials, you will come and sit down. Or you paid us, but you've not paid complete. Each time we have tutorial, you come and sit down. Be checking who is a good person and who is not a good person. You know that young children, like not like you people are children, but growing people, I believe we have opinions. When I was young, when I was in year 1, I have plenty of opinions. Like there are people I see, I have things to say about them, and I believe the case is the same with you. So you don't come and sit there and be telling if the man is a wicked man or he doesn't know how to talk to people. Please, quietly, you stay in your house. So please, you stay in your house so that once you have the money, you now come for tutorials. Do you know why we left some of you during the first semester? Is at least we still have second semester to be together. And at least we know that what you are doing in second semester is even more complex. Because there are some part of physics that in your secondary school you did not do well. Luckily for you, you are not doing waves and optics. Unlike the engineering students, they are doing waves and optics. Yes. But there are some things, those waves and optics, you still do it in your practicals. So we just left you first semester. This second semester, you must pay. Like the way I will be pursuing you, you won't like it. So please, I beg you in the name of God. I beg you in the name of God. It's better for me to have it that you're in your house. Me and you, we did not exchange anything. Then you are here, and then you now have to go out of bitterness to go and be having some resentment and things to say. Please, stay in your house. If you're not with our tutorial fee, I beg you, stay in your house. Because me, I know personally that if you tell your parents that this tutorial is wonderful, that it helps you, that it is what you want, your parents will do it for you. Most of your parents, when they look at you, they are seeing their future. When they look at you, they don't want anything to make you feel like others are progressing, you are not progressing. So once you open mouth and tell them the importance that is valuable, they will do it for you. So if you feel it's not true, your own is not working like that, come and meet me to talk to your parents. If I talk to your dad, instantly he will send the money. If I talk to your mommy, instantly she will send the money. So if you've not done the two and you're still coming for tutorial, it means you don't want to pay us. You just want to be coming here to be looking at us. And I will start pursuing you, please. Alright, so to solve this question, the first thing I will do is to bring out the charges, Q1 and Q2. I do what we call the vector diagram. I analyze it. I pull out Q1, I pull out Q2. I analyze it. They said there's a distance there, I put out the R. And I hope you know, do you know that Coulomb's law, see what the law is saying? What the law is saying is this, see, look at this. If this thing, let's say this is magnet and this is magnet, if they are closer, the closer they are, let's say they are very close, what will happen? The force, the magnetic force will be high, should be? I know it's electric we are supposed to be doing, but they are almost the same. It's just that the only difference between magnetic field and electric field is just that for magnetic field, the field and the electric field and the force itself move perpendicular 90 degrees this way. But for electric field, they move in the same direction. That's just the difference. For magnetism, force field and the force itself perpendicular. But for electric field, the same direction. So if I am analyzing this with magnetism that you've experienced, you know, if you bring this thing close, if the distance is close, like small, shall you see that this distance is small? Is it not true? Smaller distance, but the charge that will be felt here will be very high. The force will be very high. If the charge is high, force will be high because charge and force, they are directly proportional. See, from that Coulomb's law, F equals to KQ1 Q2 over R squared. That Coulomb's law. Notice that F and Q here, they are in the same numerator. For the fact that they are in numerator, it means that they are directly proportional. So for that reason, if charge is going to be high, but notice that distance is small. But the minute I expand this distance, big distance, you notice that what will happen? The charge will be small. Even if you don't look at the charge, but the attraction or repulsion will not be small. Is it not true? So you see big distance, but small force. That is just what it says. That is why sometimes if I stay in my house, I will tell myself, most of these laws that you have, they are very simple laws. Very, very simple laws. Newton's law is just throw something up, it come down. Gravity. You open your hand like this, you close it when you are testing the charge. Coulomb's law. Very simple. So most of these things are very simple, practically very simple. In our last class, somebody was asking me, how do you do gold leaf experiments? I said induction. But as we start doing the practicals, you see us using even contact method. We'll do all those things today, if time permits us. Contact method, conduction method, and the rest. So what I'm saying in essence is this. I have my charges. I have my distance. Now they say they repel each other. It simply means that I need to come and put the positive signs. Repelling each other means that they have the same sign, be it positive or negative. Okay? If the distance between the charge is reduced to 1/3, if the distance, but first of all, you had the distance of R. Is it not true? Okay, that means I'm facing two things here. Shall you see how I'm analyzing it? It's not you go inside your head. You say you are cramming it using one piece of paper. So that means that in the first case, I have this. In the second case, I'm having something like this. But this time around, the R that is here is reduced to 1/3. So two cases. They are not asking me the resultant force. That means that in this first one, if I had the first one to be like F equals to K. Remember I told you, if the charges are the same, the Q will be Q squared, Shebi? Yes. But if they are not the same, you don't have Q1 and Q2, Shebi? The Q2 there is known as the test charge. Even though we don't like calling name, but have it in mind. So let me put Q squared. The first case is just like this. The second case is F equals to KQ squared. Notice something, it's the same charge, they are the same. So F is equals to KQ1 Q2 all over R squared. This is when you have a source charge and a test charge. The minute you have the charges to be the same, I'm just doing Q squared. I remember it's the first force. Why am I doing this thing in two places? Because of the fact that they gave me a distance. And in another place, they now told me that the distance reduced. So if, for example, I hold this body, the force acting on this body when it's like this will not be the same force for an electric field. Will not be the same force that will be acting on it when it's this way. So if the distance change, the force must change. If the distance increase, the force must change. Distance increase, force will reduce. Distance reduce, force will increase. So for that reason, Coulomb's law must change. Or, yes, the force must change. The Coulomb's law I'm using will not be the same whenever I have different distance. So please, And the part where we had issues with, what is it called? Reducing to whatever. So I will now have all over 3, and this is what they gave me. But the r is raised to the power 2, so this inside this will have to be raised to the power 2 as well. So if you check it, this come here. Why am I making this come here? Because as somebody solving this, I can see that the KQ is not given. What is having effect in this question is the distance. Distance is what is determining what is happening in this question. It's not like where charge makes the rule. What is making the rule here is distance. So for that reason, I'm having this come here, having F1 r squared equals to KQ squared. Right here, having this here, this is because F2 1 over 9 r squared, which is essentially as saying F2 r squared over 9 equals to so the minute you finish this, the minute you are done with that, you can now comfortably equate the two. So that you are now having F1 r squared. Somebody can choose to do this to be equals to this, but in order to avoid confusion, somebody will want to tell me, but why is the K for this one not the same with the not K2 and this one? No, the charge is the same. The charges are the same. If you read that question, the charges are the same. Did you hear when I said this Q square that is here means Q1 and Q2? That when the charges are the same, you use Q square. When the charges are different, you use Q1 and Q2. Did you hear when I said it? So I cancel. So I'm having this here. So I have F1 r squared equals to F2 r squared over 9. Plus multiply. So that I have 9F1 r squared equals to F2 r squared. Making F2 subject of the formula because that's the resultant. I will divide by r squared. Divide by r squared. This will cancel. This will cancel. I'm left that with F2 equals to 9F1. So 9 of the first force. That is 9 times the first force. That is what F2 is. So when you reduce the distance, you can see that the force increases. That's just to show you that we are correct. So if the distance is reduced 1/3, the force is increasing 9 times. You get the point now? Yes, you get it. It's not hard. You just have to go and read, like look at it, think about it. But I want to assure you that everything I gave you in this class, everything I gave you, I know that what we are doing is just electrostatics. We've not even crossed to Gauss law of permittivity. So everything I gave you in this class is me trying my best to cover everything that has to do with electrostatics completely. So in our next class, we start with Gauss theorem, then from there we move to chapter 2, and permittivity, electric flux, electric field intensity, and the rest, even electric field potential. So please, question 9 and 10 of the first exercise, try your best to look at it. Try your best to look at it. So let's do mathematics now. Let's do maths. Atoka?